Hi, my name is Madhav Arora and I welcome you to the course Spring Boot with API and Performance Testing Crash Course. This is a course intended for anyone who is interested in learning about complete development, testing and deployment lifecycle for a Spring Boot microservice. So what we'll be covering as part of this course? In this course, we'll first get a brief understanding of microservices. Building on that knowledge, we'll create a Spring Boot application. We'll take our Spring Boot application and write API tests for it using Postman. After validating that our API tests are running fine, we'll do a performance testing of our app using Artillery. And finally, we'll be deploying our app on Pivotal Cloud Foundry. Even though it's mentioned as a crash course, but we'll still be covering all the essential details required for a beginner Java developer who is getting into Spring Boot application development. If you like the content, please do like, share and subscribe this video, and if you have any feedback, post a comment in the comment section. Course is divided into 5 sections. In the first section, we'll get a brief understanding about microservices and Spring Boot. In the second section, we'll be creating a Spring Boot application based on a hypothetical scenario. In section 3, we'll write API tests for the app created in section 2. In section 4, we'll write the artillery script for doing performance testing of the app, and finally in section 5, we'll deploy the application to PCF. By the end of the course, we'll have a running application on the cloud. We'll be covering section 1 and 2 in this video. Section 3, 4 and 5 are available as part of the course on Udemy. I'll leave a discounted link for the same in the description. Welcome to the course. Let's see what we'll cover as part of this section. So in this section, we'll get a brief understanding of microservices, and we'll also understand that how Spring Boot apps fit into the whole microservices architecture. Thank you. Welcome to the course. So in this lecture, we'll understand about microservices. Before delving into what a microservice is, let's see how we were building applications in the past. So in the past, if you see any application which was built, it was built using an architecture known as monolithic architecture. So in a monolithic architecture, you'll always have modules in a big monolithic application. So let's consider the example of an e-commerce application. In any e-commerce application, you will find these functionalities like cart, product detail page, product listing page, search function, checkout functionality, and returns. With this monolith, which had all the different modules, we go ahead and we deploy it on a server, which was usually an in-house server. Now the times changed. So it was the new time and the cloud came. So everybody started deploying on the servers which were on the cloud. So we get the cloud now. With the cloud technology, there came new functionalities. Like in case of high demand, which usually is during the holiday season for an e-commerce application, people used to access the e-commerce websites a lot. So what was the feature that the cloud offered? That you can spawn new instances of your e-commerce application. So when the high demand comes, you have these multiple instances of these big monolith, which was a huge impact on the size and your hardware requirements on the cloud side. Since it was a cloud, so you had additional cost when new instances were created during high demand. We face certain challenges with a monolith application. Let's discuss them. Applications get huge when we have so many modules built into one single app. With every new functionality, we have new modules added in the app. The end result is a huge and a bulky app. Now imagine you have to make a change in one of the modules, like cart module. How can you make sure that you haven't broken any other functionality? There is only one way. You need to test the entire app. Let's move one step ahead. You changed the app, tested it as a whole, and now it comes time to deploy it. Can you deploy only the cart module? Nope. You need to deploy the complete app, since cart module is part of the complete app. So these were the challenges that we had with the monolith app. Now came the microservice, an entity which can be deployed and scaled independently with its own embedded server, like Tomcat or JD, and whole new way of developing applications. This whole new way got called as microservice architecture, and it had its own defined patterns of microservices development and its deployment on the cloud. Now we had a set of independent microservices which we were deploying on the cloud. Let's go back to a previous scenario. Now all of our microservices are on the cloud. In the event of a high demand, cloud will spawn new instances based on the in-demand microservice, which as a single entity is of very small size when compared to the big monolith. Now let's assume that the users access the product listing page, search, product details and cart more. So more instances of these microservices will be created, and once the demand ceases, then they will be downsized. Instances for checkout and returns will remain constant since there wasn't much demand for these services. So we'll only incur cost for the service which are getting used more. Let's look at some more benefits of the microservices architecture. Now when we have to change something, let's say in the cart microservice, we don't need to test all the microservices. Till the time the test for cart microservice is passing, we are good. Since the team was focused on this one service, there is definitely productivity improvement. And when we have made the change in the cart service, we can deploy only that service. And as discussed, when we have to scale a microservice, since they are small in size and functionally focused, they can be scaled easily. Hi, welcome to the course. In this video, we'll learn about Spring Boot. So what is Spring Boot? Before answering that question, let's understand what is Spring. Spring framework is a powerful, lightweight framework which has been used for application development since many years now. And it has become one of the de facto standard for developing enterprise applications. And it has various modules which make this framework a favorite for all the Java developers who are developing Java enterprise applications, right? Who are developing enterprise applications. As you can see that there are a lot of modules in Spring Framework and it's very exhaustive. So it's not in the scope of this video to discuss this. So let's look at some of the features of Spring. Spring Framework is, let's go to the first one. The Spring Framework is lightweight. What does it mean by that? So it works on POJOs. POJOs stand for plain old Java objects, and that is what makes it lightweight. So it doesn't forces you. It never forces you to inherit or implement interfaces, right, or classes. The second one is there's a concept called aspect-oriented programming, and it's a very good concept. It is used for separating cross-cutting concerns. So in any application development, we have various cross-cutting concerns, right, like logging, security. And if we have to deal those with our business logic, then the code becomes very complex, right? You have repetitive code everywhere around your application, and separates your cross-cutting concerns from your business logic. The third thing is transaction management. It's self-explanatory. It has the capability to manage your transactions. Yeah, so you don't have to do it yourself. The next thing is container. So framework provides you the container which manages the life cycle of objects so that you don't have to worry about those yourself. Then, so the golden feature of Spring, which was advertised when Spring came out, was dependency injection. So as per this, so Spring container injects your dependencies, which allows for loose coupling of components. So you don't need to worry about your dependencies. So it will automatically inject your dependencies when you request it. So next one is integration with other frameworks. So if anybody who has worked in Spring, he'll agree to this point that it can integrate with any framework that you can think of. Like I have never encountered a framework in my life that Spring is not able to integrate with. So as we discussed previously that it's a very huge framework. There is a way to integrate it, but you need to provide proper configurations for that. So let's move on to the next portion of it and let's see whether we have any issues with Spring or not. There's a problem with Spring, and that is configuration. So it requires a lot of configuration and it's a big pain to remember those configurations. Many people will list several other issues with Spring, but I feel that this is the one that stands out. So I think this is the major reason they created Spring Boot for, because anybody who started learning Spring, they were overwhelmed with the type of and the quantity of configurations they need to do for setting up their project and for integrating it with different frameworks and different tools. So let's look at the Spring Boot now and let's see if it resolves this issue. Spring Boot features. So the first feature is framework is built over Spring. What it means is that it makes it easy to create standalone applications because under the hood it's using the same concepts that Spring is using. In fact, it is using the same dependency jars eventually that Spring is using. So it has the same strengths that Spring has. The next one is opinionated. So that what it means is that they have configured the framework to work in a certain way, and if you have to change that, you can definitely do that. But for most of the things, they'll check for some specific dependencies in your class path, and depending on that, they'll introduce some new dependencies. So you will get a certain flavor of doing things, and if you're not happy with that, then you'll have to delve deep into your dependencies and change those configurations. The next one is minimal configuration. So the auto configuration is a concept which is heavily used in Spring Boot. The thing with auto configuration is that it will take care of a lot of things for you, so you don't have to do it yourself. So this was the problem which was existing in case of Spring. With auto configuration, they have tried to resolve this issue. So they auto configure based on what all dependencies are there in your class path. Based on those dependencies, they'll configure certain things, and for most of the stuff it works just fine. But for some scenarios, it might be a problem for you. So in those cases, we need to remove the auto configuration by introducing some new dependencies, which takes care of things in a different way. So the next one is there is an embedded server. So this I think we discussed in the microservices lecture as well. So Tomcat is embedded by default, and it helps in running your Spring Boot app as a microservice in the cloud. And Tomcat is not the only option. They also have Jetty and Undertow. So you just need to tweak a small configuration to get them enabled. And they have this concept of starter dependencies. So the starter dependencies actually are dependencies which they assume you need a group of. Basically, once you give this dependency, they'll automatically include 3-4 different dependencies with that. So to take an example, we have this starter dependency web. So once you include the starter dependency web, they'll assume that you'll use Jackson for JSON responses. So they'll include the Jackson dependencies. Then they'll also configure the Tomcat as the embedded server. So these are the kind of things they'll do with starter dependencies. So such dependencies exist for everything. So for JPA, Java Persistence API, they have a separate dependency. Okay, so the next one is metrics and health check. They have provided the concept of metrics and health check. They actually expose two endpoints as soon as your app is up. One is info and the other is health. So these endpoints actually tell you that how your service is behaving in the cloud. So they are very helpful. You just need to include another starter dependency, which is actuator, Spring Boot starter actuator. So once they see that this dependency is there, they'll automatically expose these two endpoints, and then you can just configure those in your properties file, which will actually give you more information with these endpoints. By default, they don't give much information. They just say that your app is healthy, it's okay, or it's failing. So that's all about Spring Boot features. In this lecture, we have covered the basic features of Spring Boot and what it offers more than Spring. Thank you. Hi, welcome to the course. So in this section, we'll be building a Spring Boot application. But first, let me share with you the inspiration for the app. Yep. So there is this show called Voyager. It's part of the Star Trek series, and it came around 1995 to 2001. So Voyager is a starship, and like any starship, it wanders around space exploring different planets and star systems. Now a starship needs a crew. So it has a crew. So it has a crew of around 200, and the crew is divided into different departments. So let's look at how it's structured. So these are the 4 different crew members. So Janeway works on the bridge, Tuvok works in the tactical department, Belana is engineering, and Kim 2 works on the bridge. Okay, so considering this use case scenario, we'll be building an app. So what will we build? So we'll be building a Spring Boot application. We'll call it a Voyager application. So it will be a Spring Boot app, and we'll be communicating using the JSON request and response. Okay, so that would be the request and response structure. And we'll have basically the REST-based services, and below would be the endpoints. So we'll have two get endpoints and one post endpoint. So the two get endpoints will be used for fetching the information about all the crew and a specific crew respectively. For the first one, get crew, it will give you the information about all the crew, and the second one with an ID, it will give you the information about a specific crew based on the ID, and the last one will actually post the crew. So let's see. Yep. So this request structure, the response structure for the get crew will look something like that, and response for the get crew ID will look something like that. And regarding the post crew, since it's a post call, so it will have a request and a response. So your request will look like this. So here in the request for post crew, we'll be saving Janeway and the department as bridge, and the response that we'll get is we'll get back the same Janeway and the bridge as the value, and along with that the system will get back to us with an ID. So we'll be saving all this value in the in-memory database called H2 database. So in this part of the course, we will be building this application, and in later part of the course we'll be testing this application using Postman. We'll write API test, and we'll also see how we can performance test this app using Artillery load testing tool. Thank you. Welcome to the lesson. So in this lesson, we'll create a new Spring Boot application for our Voyager microservice. So I'll start with opening the IntelliJ IDEA. So I'm using the community edition. So once it opens, I'll create a new project. Yep. So once inside the new project, I'll make use of the Spring Assistant option. So in the Spring Assistant option, I'll use the default setting which points to start.spring.io. I'm using my project SDK as 1.8. You can use any higher version if you want to. So I'll click on next. So once I go to the next screen, it asks me for certain values. So I'll just fill some values related to the project. So I'll say Voyager as the artifact ID. I'll keep the other values as same. I'll set the project name as Voyager, project description as microservice for Voyager, microservice for Voyager, let's say, and then I'll give the package name as com.madhav.voyager. So I press on the next button. So in this screen, we give various dependencies related to the project. So I'll select few dependencies that I want in this project. So I'll select web, Spring Web, and I'll select H2 in-memory database, and I'll select JPA. So once I'm sure that these are the dependencies I want, I click on the next button. It gives me a default path. I'll just modify this a bit, and I'll click on the finish button. So it asks me, it informs me that this directory does not exist, and it's going to create all this directory path. And I'll click on OK. So once I click on OK, it opens me the project. It gives me some random tips. I just click on close. So once I'm in the project, you can see all the dependencies that we asked for. They are part of our pom.xml. So let me open the pom.xml. So in our pom.xml, we have these dependencies. So this is for the H2, and this is web and data JPA. So these three dependencies are there. So this was the first lesson. So in this lesson, we have created an application and with the required dependencies. Thank you. Hi, Welcome to the course. So in this lecture, we'll go to the Spring Initializer URL in the browser and we'll try to create a project from there. So we did the same activity in the last video using IntelliJ IDEA, but this time we'll do that in the browser. So let's go to start.spring.io. So once we are here, we see that we have very similar options that we had in IntelliJ. So we'll keep on using the same options. So I'll keep the Maven project selected, the language as Java selected. I'll even use the same version, and let me modify the group name as com.madhav, artifact as Voyager, and let me see what all options I have. So I'll give it Voyager. I'll say that it's a microservice for Voyager, and I'll keep my package name actually the same, and I'll be using the same Java version. Okay, now let's go ahead and select our dependencies. So we need the web dependency. So I'll just type in there and I'll add the dependency. Next is JPA, and the next one is H2. Yep. So once I have these dependencies, I'll click on the generate button. So once I click here, I see that there's a zip which gets downloaded in my downloads folder. Now I'll go to my downloads folder. So let me go to downloads. So in my downloads, I'll click on show in finder. So this is the voyager.zip that got downloaded. So I'll just double click it. So it has unzipped it. So now I have my project here. Now let's open IntelliJ and try to import this project. So in IntelliJ, I'll do an import project. So in my import project, I'll go to the downloads folder, my Voyager app, and select the pom.xml. So once we give it the pom.xml, it automatically identifies it as a Maven project and it tries to import all the dependencies. So as you can see that it's trying to resolve all the Maven dependencies for our project. Yep. So our project is imported successfully with all the dependencies that we mentioned there. And you can see that we have our main application class. So it's the exact same structure that got created with IntelliJ. So we can just start our implementation on this version as well. Thank you. Welcome to the lesson. In the previous lesson, we created the Voyager application with few dependencies. Let me quickly go to the pom.xml file. So as you can see that we had these dependencies added to this project, like H2 dependency for the in-memory database, Spring Boot Starter Web, and Spring Boot Starter Data JPA. Now in this lesson, we'll continue creating and implementing the microservice. So first of all, we need to define our model. So I'll create a package for my model. So inside my models package, I'll create a class called crew, which will stand for the model. So what all the model will contain? So my crew will have an ID to uniquely identify a crew. So it will be of type integer. Let's say just it's an ID. My crew will have a name. Crew will have a name, and my crew will belong to a department. So department. Now I have to convert this model into an entity. So I'll make use of entity annotation, which is inside javax.persistence package. And I also want to define and tell the Spring that this is a uniquely identifiable field. So this is my primary key, and I want to auto-generate it. generated value. So after using these annotations, I need to create getters and setters for them. So I'll say generate getter and setters. I click on OK. Yep, so all my getter setters are generated now. Now I'll go ahead and create a new package for the repository. So I'll create a package. I'll define it as repositories. I'll create a new class. Okay, so I'll name it as crew repository. So in my crew repository, what I'll do is, so basically it will not be a class, it will be an interface, and it will extend JPA repository. How we define it is, we define it using the entity and the primary key in that entity. The type of primary key in that entity. So it's integer. So apart from this, we don't need to write any code in this, because JPA repository, by just extending the JPA repository, it gives us all the default implementations for find all and find all by ID and all those methods. We'll see those in detail when we'll use them. So I've defined my repository, and now I'll give it an annotation of repository, which is just an extension of add component annotation, and just tells the Spring framework to auto detect this. Okay, so the next thing that I'll do is I'll create my service class. So for creating my service class, I'll create a new package in which I'll put all my services. I'll name it as crew service. Okay, so in my crew service, now I need to write some business logic. So what I can think of is I'll write a method which will give me a list of crews. I'll say get all crew. Let me just import it. Yep, so I get all the crew. Okay, the next method will return me a specific crew. So get crew. I give it an ID. Yep. So based on an ID, it will give me return a specific crew. And the next method, I'll say save crew, basically post crew. Teacher, let me name it save crew. And it will accept a crew. Okay. Now let's start defining. Basically, let me get a reference for the repository that I just defined some time back. So private crew repository. So the best thing with IntelliJ is it gives you auto suggestions, and it's way better than Eclipse. So yeah, it's pretty good. It saves a lot of time. So I'll just define it as a component, and I'll auto wire the repository. Okay, so now if I have to get all the crew, I have to simply do like repository dot get find all. So it will find all the values, and I'll simply return it. Similarly, for getting a specific crew, I'll do repository dot find by ID, and I'll pass an ID. So if you see here, I'll get an error because it is expecting an optional and I'm giving it a crew. So the thing is, if I pass an ID, there could be two cases, that my crew exists or my crew doesn't exist. So that's the reason it returns an optional. So let's assume that the crew exists for now. Okay, so we'll handle it in the later part of the course, where we'll return a proper error message telling the user that the crew does not exist. So for now, we'll assume that it exists, and we'll simply return that. Okay, so for saving the crew, I'll say repository dot save. Yep, so I'll pass a crew, and it will return back a crew with like whatever values it has saved for the crew. Okay, so this is the implementation for the service. Now we need to write a controller. So I'll create a new package called controllers, and I'll define my controller in it. Crew controller. Okay, so in my crew controller, I'll define certain methods which will return the specific values. So public, they'll be very similar to what I've defined in my service method. Okay, so list of crew, get all crew. I just need to import these classes. Yep. So another one that I'll define is public crew get crew. So this will have a specific value. Basically, based on my ID, it will return me the crew. And the next one would be for posting the crew. So in the normal HTTP terminology, we have the get and the post. We have other things as well, like put, delete. So for getting the values, we use get, and for saving the values, we send post call. So in my post crew, I'll say crew. Okay, so now I'll get a reference for my service. So I'll say private crew service, and I'll autowired. I'll say service dot get all crew. I'll say simply return it. I'll do return service dot get crew. I'll pass an ID, and in the post one, I'll say return service dot save crew. I'll pass the crew. Okay, so now we need to tell the Spring framework that I'm going to pass. Okay, so before that, we need to define our mappings. So for all the get methods, I'll define get mapping. I'll say crew. So what it does is, so in the browser, if I'll do /crew, it will return me all the crew. Usually we test the REST-based services using a tool called Postman. I'll introduce that tool in the next video. So we'll be using that, but the get calls you can even make in the browser. But we'll be using that tool for making the get calls and the post calls. So for the next one, I'll say get mapping. I'll say get me a specific crew for which I'll pass an ID. And now I need to tell the Spring container that I'll be passing this ID as a path variable. So I'll define that ID will be received as a path variable. So in case of post mapping, I'll do the post on the same crew, but this time I have to tell the Spring container that, sorry, the Spring framework that this is a request body. So I'll get the crew as a request body, and of course, this is not, it's a REST controller. So we have defined all these values. So basically we have defined a controller now. Now we need to make some changes in the application because we have put our controller, our service class, our repository, our models in specific packages, specific places. So we need to define certain values in our application. So first I need to tell it to scan for the components. So I'll say scan for the components. So base packages. So scan all the components on the base path, right? And the next I'll tell it to scan all the entities. So for now all my entities are in the model, in the models package. So I'll say com dot madhav dot voyager dot models, right? So next I need to tell it to enable JPA repositories on this specific path. So you'll find all my repositories in one path. com dot madhav dot voyager dot repositories. Okay, repositories. So once I've done all this, the next step that we'll do is we'll try to enable certain properties, cancel it. So enable certain properties in application.properties. So I'll say spring.h2.console.enabled equals true. So this will enable all the queries that are fired to the H2 in-memory database. Yep. Sorry. So this one will basically enable the console. I'll show you the H2 console in the next video, and the next annotation that we are going to use is for showing the SQL. So I'll put it as true. Let me reduce the space. It looks good without that. Yep. So once I've set these properties and I've defined the various paths to our repositories and to our entities, I think we're good to start. So let me just run this. Okay, I already have this defined. So in case you don't have it defined, you can just click on this, click on the add application and search for your main class. So I'll search for, let me just name it. So I'll name it Voyager Enhanced. Okay, so I'll just tell it to run the Voyager application. So using this window enables us to give us some enhanced options like VM options and environment variables and all those things. Okay, so I'll just click on run and let's see if it runs successfully or if you get any errors. Okay, so it has run successfully, and you can even see that it has created a table inside the H2 database. So in the next video, we'll persist some values in the table and we'll try to run all the endpoints that we have defined, right? Thank you.
Hi, welcome to the lesson. So in this lesson, we'll be installing the Postman tool on Mac, but you can follow the instructions similarly on a Windows machine as well. So first we need to go to postman.com/downloads. So once we click on this link, we can see that there's an orange button with an Apple logo. So if you're on Windows, you'll get a similar button for the Windows with a possible Windows logo. So just click on the download button. So once you click on the download button, it starts downloading the app. So once it gets downloaded, yep, so you can go to its location. So it's in zip format, so you can just double click on it. So the iOS will automatically unzip it. Yep, so once you unzip it, you have the application. You double click on it, it will start installing that. So it will give you this warning that it's an app downloaded from the internet. You just click on open. Yeah, so it will ask for your permission to move this app to the applications folder. So you can tell it to move to applications folder. So these steps have nothing to do with the Postman. They are the normal steps for installing any application on Mac. So once you have it there, yep, so it will open the app. Yep, so this is the UI that you get once your app is open. So it gives you various options. So let's go through some of the options. So collection is a way to organize your requests. So let's say I create a collection and I just name it dummy collection. So inside your collections you can add requests. So let's say I want to add a request. So let's say I say test request, and so if I just save this and open this, I can change it, save it. If I want to delete a collection, the easiest way that I could find is just highlight this, click on the delete button, and it asks you for whether to delete or not. So this is the Postman app. We'll learn more about it in our due course, in the next steps of the course. Yep. Thank you.
Hi, welcome to the lesson. So, as part of the previous lectures, we created the Voyager application in which we wrote endpoints to persist the values for the crews and also to query the crews, like query all the crews or query a specific crew based on the ID. So in this lesson, we'll try to test this application. So test as in we'll just check if it's working fine or not. All the endpoints that we have exposed, they are working fine or not. So before doing that, let's go to the H2 console first. So if you remember in our previous lessons when we were adding dependencies, so we added one H2 dependency, right? So we added H2 dependency and we also enabled H2 console in the properties file. So let's go to H2 console. So let me open it again so that you can see it clearly. So if you just hit on localhost port 8080 h2-console, you'll see this window open in your browser. So just check the values, they should be the same, and click on connect. So once you click on connect, you land onto this view, and you can even see that we have one table with the name of crew and all the columns as per our configuration. So currently if I just do select star, so you'll not find any values because we have not yet persisted any value in that table. So let's do that. So insert into crew values. So what are the values it is expecting? It's expecting an ID. So I'll just give a random ID and I'll give a department, let's say engineering, and I'll give the crew name as Lana. Okay. So now if I run this, I see that something got inserted. So you can see a value which is inserted there, right? So since our service is already up, let me show you in the browser itself how this value looks. So if I go 8080 and I do crew, I should be able to see the value that I persisted here, right? And why crew? Because if you go to our controller, this is one of the endpoints, get endpoints that we have defined. So get mapping crew, get all crew, right? I can even test this get mapping using the browser itself. So if I give, let me persist one more value so that it's more clear. Oops, sorry. So let me delete this. Okay. So let's do bridge and let's say gym. Okay, so if I do this, okay, I need to change this. So I give another unique ID and I run it. And now if I do, okay, now if I do, okay, it's okay. So if you check for all the crews, you will see that the gym value got persisted. Now if I ask for gym, I get the specific record for gym and the department bridge. Now the thing is how to test the post mapping. So to test the post mapping, you need to send the crew as a request body that you cannot do in the browser. So for that, we'll make use of Postman. You can open Postman. So this is the Postman. Let me open it afresh so that there are no references from my past experiments. So I open Postman. So if you have installed Postman, you will probably land into the view that I'm going to show you. It will be all blank. There will be no projects, no requests. So as you can see, you don't have any collections, you don't have any requests. So what I'll do is I'll create a collection. It's not mandatory to create a collection, but it's always a good practice, because when you have a lot of requests, it's always a good thing to put them and organize them into collections. So I'll create this as Udemy lessons. So once I'm in this collection, I'll create a new request. I'll add a request. I'll name this request as Voyager, and I'll save it in that same collection that I've created. I click on Voyager. So this tab opens, right? So here I can give the kind of request that I'm sending. So let's send the same request that we tested in the browser. Let's fetch all the crews. Okay. So as you can see that it is able to fetch the values of the crew. And let's fetch a specific crew. So I've asked for gym, I'm getting gym, right? The same way if I ask for Belana, I should get that too, right? Now I need to save a new value. So what I'll do is I'll copy this, I'll go to post, and if we now check our post endpoint, it also sends the request to crew, right? It's same as get, but the only thing is that it's a post instead of a get. So I'll go to crew, I'll post it here, and in the body, now I need to select the raw from here, and instead of text, I'll select the JSON, and I have to just post it here. I'll remove the ID thing because we are generating IDs, we are auto generating them, right? So let's give to walk, and to walk is tactical. Okay, so now let's send this. So whatever value I sent, the same value I received, and now I can see that I've got an ID because this ID got auto generated. Now if I'll do a get on all the values, let's see if we get to walk. So you can see that we got to walk, and we also have the other values that we persisted there. So till now we have made use of H2 console to persist the values, right? But you don't need to do that always, because if I restart this, I lose all the values, right? I can actually show you that. So if I just restart this, so once it restarts and I yep, so you can actually see that it creates the table again because it's an in-memory database. So once your server gets restarted, all your data is lost. So now if I go to get Voyager, you should see that I should not get any values. So see, I get a blank array. I don't have any values. So what we need to do now, so let's say I just want the values when okay, so when the server starts, I want those values to be there in the database. So I'll create a new file inside the resources, and I'll name it, let's name it, so data.sql. Okay, and I'll copy one query and make use of it. So I'll just copy it here. I'll delete it later once I have my insert queries. So I'll say insert into crew value. So it expects an ID. Let me give an ID, some random ID, and let me give a department engineering, and name, let me give Milana, and I'll do insert into crew values, and some unique name, and let's say tactical, and I'll say to walk. Okay, so now let me delete this. Oops. Okay, so now I have these queries. Okay, now let me just restart this. Let's see if we start seeing these values there. Yep, so my application is started. Let's go to Postman. Let's make a get call. So now you can see that these values got persisted, and you can actually confirm this in the H2 console as well. So if I go this, go to H2 console, and I do crew, you can see I have these values. So now in this lesson we have added the values, we have queried the values, and we can even get a specific record based on these values. Okay, see you later. Thank you.